Hi guys, here we go. Unit 10, Day 3, Notes, Growth and Decay Application. So word problems, almost all of these problems, most of it is in the calculator. We set it up, we kind of organize everything, but then we type it in the calculator. So if you don't have your calculator out next to you, like right next to your paper, pause, go find it, come back, start the video over. You literally have to have your calculator if you want to get any of these problems right. I'm going to talk you through a lot of the steps. So while I'm talking, you should be clicking in the calculator. Okay, you don't have it. Go get it. Here we go. Example 1, jumping right in. There is a pond stocked with 200 fish. The Department of Wildlife expects the population to increase at a rate of 5% each year. How many fish will there be in the pond after blank? Okay, first part of the problem says write the exponential equation to model the situation. Just a reminder, growth y equals a1 r power. Decay, almost the same, almost. However, this has a 1 minus r on the inside instead of a plus sign. But really, you're plugging in, one's a growth, one's a decay, you're plugging in the same way. This one, they're expecting the fish to increase, so there's going to be more and more and more fish. I'm going to use the number 1, and I'm going to plug in what I know. I know that there are 200 that they stack in the pond. I know that the rate that they're increasing is 5%. Remember yesterday we worked backwards on that? We got 0.05. So for my rate, I put 5. No clue. Model. Wants the general. So there's my model. Now this next part, we do terms like this. How many fish will there be in the pond in 5 years? Round down to the nearest fish. And now it says, well, what if T is actually 5? I'm going to back up. Read everything. And instead of the letter T there, I'm going to put the number 5. Because I want to know how many years after 5 years. So, exactly match up perfectly round down, which means it's about 255 fish that are in this pond after 5 years. Started with 200, after 5 year time span, at 255. Calculator, right here, the screen part, have to type it in. Okay. Now, between how many years will the amount of fish double? So it started with 200 fish, but now it wants to double the amount of fish. So it wants to know, well, how many years will it take to get 400 fish? Right? Started with 200, double that, that's 400. How many years? How much time? That's what they're looking for. How much time? 6 years, 7 years, 8 years, 9 years, whatever. How much time will it take to get the 400 fish? This is where we use these steps in our calculator. So what you're going to type in the calculator is we're going to take the y, which is 400, so we put that in for y in our equation. So we're going to have 400 is equal to, well, we started with 200 fish. They grew at a rate of 0.05, and they want to know, well, how much time? So here's the y, the double fish. Here's everything I had before. We're trying to figure out t. This is where you type in the calculator. You type this 400 into y1, like we normally do. This is the weird part. You type this other piece, this red piece right here, into y2. Okay, t is just a variable. If that confuses you, you could put an x there. That's all your calculator has is a little x button. You take that, okay? You hit the button second y equals. So get it on, second y equals. Oops, sorry. Back up. Turn it on. Just y equals. Sorry. Messed up. Just hit y equals. In y1, which is the first one, you just put the number 400. Go down one spot, right below it, in y2, you put 200, 1 plus 0.05, raised to the x. So take a second. That should literally look the same with the decimal, x power. All of that should look good. You have a plus sign, all of that stuff. Everybody okay with that? That was step 3. We're already on step 3. Okay. Step 4 is click window, which is up at the top, and adjust. So in this box, this fancy box here, we gave you a new window. So this blue box right here, you need to adjust it. Everything looks good, except for you need to find X max. You need to change it to 20. You need to take Y max and change it to 500. Okay. Then, step 5, click second trace intersect. Second trace. Go down to intersect. Your graph should come up. It should look like a line, and then something is going through it, kind of like a diagonal-ish thing. You have that little cursor, the dot, the blinking dot that comes up on your calculator. You want to move it over so that it's on the spot where they're crisscrossing or they're touching, and you want to find that spot. You want to hit enter 3 times, just right on that spot. Give your calculator a second to think. It'll give you an answer. My calculator on the bottom, right on the bottom, said x is equal to 14.2 and y is equal to 400. On the bottom, what that means, the x, that is your time. This is what you want. That means it's going to take about 14.2 years to double the fish, population. And then you're done. So we wanted 400 fish. Well, they'll get 400 fish, but it'll take 14.2 years. And we had to do all of that in our calculator. Okay, next one. In 1998, the cost of tuition at a state university was $4,300. During the next 8 years, the tuition rose 4% each year. The following rates happen forever. Write a model given this tuition and all these pieces. So, going through this, I have 4,300. That's my initial value. That's how much it takes. Okay? During the next 8 years, the tuition rose 4%. Okay, I write my model. It is a growth. So it should be y equals 4,300. 1 plus 0.04 to the t power, because it wants to know how much time, right? This is my model. So then it says, between what years will the tuition be $20,000? Well, this $20,000 is like your final answer, your end game. Okay? Between what years? It's looking for t. Time? I don't know. That's what we're trying to figure out. Then we take what we know. That we want it to be 20,000. That's y. We already have our other stuff. We have the a, we have the 1 plus 0.04, we have the t, which is x, and I type it in my calculator. That first piece goes into y1. That whole second piece goes into y2. You hit the button y equal. y1, you put in 20,000. So get rid of that old stuff. Put in the new stuff. Put in 20,000. In y2, it's right underneath it. You put the 4,300 times 1 plus 0.04 to the x power. Okay, I get it all typed in. It looks pretty good. That's in my calculator. It says next step would be changing the window. It says on the side, again, let me highlight it blue, what your window should be. So on the top, you have that button that says window. If you need to make a reminder, window is the button you hit. Change it, right? Make your X max 50, your Y max 25,000. Other stuff is fine, whatever. When you got it all adjusted, second trace, go down to intersect. the blinky guy, you want to move it over. Your calculator will give you the answer. It'll say on the bottom, x is equal to 39.19, is y is equal to 20,000. That's what you can see on the bottom. What do we want? We want this x right here. That means almost 39.2 basically years. That's the time it'll take for the tuition to be $20,000. After about 29 years, that's how much money it'll be. Okay, flip it over. You buy a new car for $24,000. The value of the car decreases by 16% each year at an exponential decay, and then let's find a couple pieces. So, $24,000. This is A. How much it costs right away. This is decreasing. Huge. We have a decrease equation, a decay. Is decreasing at 16%. So I take that 16%, I rewrite it into a decimal, that's 0.16. Let's write my model. Y equals 24,000. 1 minus. Why did I put a minus? Because it told me it's decreasing. It's a decay at 0.16. And then I have my little at the top. That is my model. Okay. So now let's see what else they gave me. Estimate the value of the car after 2 years. Talking about money here. Round it up. Or round it right, sorry. Okay, money. We have 10 cents, 15 cents, 35 cents. So that means we could go to 2 decimal places. So I read that wrong right away, not round it up, but round it right. That means we could go to 2 decimal places. Okay, anyway, let's back up. Estimate the value of the car after 2 years. 2 years would be T time. So I'm going to plug it in. Y is equal to 24,000. 1 minus 0.16 raised to the 2. 2 years, right? You plug this into your calculator. Literally, nothing fancy. Go to your normal screen, like the main screen, which is kind of blank. Just those numbers. All right, calculator. Just that. Nothing fancy. No graph. Nothing. You type this in exactly like that. Your calculator will do the work for you. You're talking about money, right? So it'll give you $16,934.40, right? 2 decimal places, 40 cents. So almost $17,000. You paid $24,000, but you know, you drive the car, wear and tear. You drove it around for 2 whole years. Now it's not worth as much. Okay. Your mama's car is now worth $5,000. You bought it 6 years ago and you expected it to decrease 15% each year. How much did you buy the car for originally? It's money. Round appropriately. 2 decimal places, right? So this one's a little bit harder. I'm going to make another video so I don't have to speed it up and kind of cut it too short. So I'm going to say Unit 10, that's the unit we're in, J3 video, I'm going to say part 2 for this example. I'm going to say go watch. Make sure you know how to do these. Go watch. Okay, if you're stuck, you need more practice, go watch this one. I'm going to do it on another video so I don't run out of time. If you don't know how to do the other ones, I'm telling you, you need your calculator. So get the calculator, watch it again, or pause it, rewind it, make sure you're hitting those buttons. On the front of the notes, let me backtrack. Very beginning, it gives you 6 steps. 6 steps right in the middle here. Those are the steps you follow to get the calculator steps. Okay? If you're stuck, make sure you go to resource room, ask your teacher for help, watch the videos. I'm going to put that part 2 out in a second.